In this lesson, we're going to talk about how to graph from an equation. First, I'm going to give you a big overview reminder and then remind you about slope-intercept form and then talk about how to graph from slope-intercept form. First, I know there's a lot on this page, but remember that a graph is a picture of all the solutions to an equation. So when we're creating a graph, we're creating a picture of all of the solutions to an equation. These solutions to these equations also represent the relationship of the inputs and the outputs of a similarly defined function. So the x's are the inputs and the y's are the outputs of a function that has the same format as that equation. A line is made up of infinitely many solutions, which are represented as points on the line. These points may or may not be marked. Remember, just because it's not marked on the line, if there's a line there on the line, anything is a point that can be a solution. And number 4, linear functions can be represented by tables, equations, and graphs, and all of these can describe the very same linear function, which pairs the same x's and the same y's. So now let's talk about slope-intercept form. So again, linear equations are frequently written in slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. Slope is the steepness of the line, and then the y-intercept is the location of the line. So let's graph y equals 2/3 x minus 5. First, I recognize that this is in slope-intercept form, and that the m is 2/3, that's my slope, and the b is -5, which that's the y-intercept. So that represents the point 0, -5. Now, remember the slope is the steepness. That's how steep our line is going to be. And the b is the location of one point that our line will go through. So it makes sense to begin with the location of the line first and then go from the steepness. And if it helps you remember, b is where you begin and then m is how you move from that point. So we begin at 0, -5, and then this is our rise, and this is our run. So I'm going to run 3, 1, 2, 3, and then I'm going to rise 2. And you could do that a couple of times because every run of 3 and rise of 2 will give you another point on the line that is a solution to this equation. And then you're going to use a straight edge tool to draw a straight line. Make sure that it goes all the way through the graph and that you put arrows at the ends because the arrows indicate that this line goes on forever in both directions and that it never stops. And it's really important that it covers the whole graph because eventually later in Algebra 1 you'll solve systems of equations and you'll want to see where two lines intersect. And if you don't make it cover the whole graph, you won't see where they intersect. For those of you who like to follow steps, here are the steps to graph. First, check that the equation is in slope-intercept form. If it's not, you can put it in slope-intercept form. Then graph the y-intercept. This point is always 0, b. Then use the slope of the line to create more points. Remember, slope is rise over run. And then use a ruler or a straight edge on your computer, straight line on your computer to draw a line that extends through the points, placing an arrow on both ends. Let's look at a couple more examples. So let's graph y equals 3x plus 1. M is 3, b is 1. And again, that represents the point 0, 1. I'm going to begin with b, which is my y-intercept, and then I'm going to move my slope. Now, this doesn't look like it has a rise over run, but you'll remember that 3 is equivalent to 3 over 1. So from here, I can go up 3. Oops, I want to do my run first. It doesn't really matter, but I try to stay consistent. So I'm going to run 1 and rise 3. Run 1, rise 3. And now you can see how steep my line is, and then I'm going to use my straight line tool to create a straight line with arrows at the ends. And there you have it. And now by creating this line, I know that this one, 0, -2, this point right here is another point that's another solution to this equation. It's another point that's on a line. In fact, any point on this line, here's one, those are all solutions to this equation. All right, we're going to do one more example. This one's a little bit different because it doesn't quite look like the last ones. So the m is the coefficient of x, and when there's no number here, there's an understood 1. So m is -1 in this case because it was a negative x. And then when there's no y-intercept, I could put a +0 on this equation and it's identical to the equation before. So the y-intercept is 0, which means this line goes through the origin. So again, I start with the b, which is 0, and then I'm going to write this as -1/1. So my run is 1 and my rise is -1. So I'm going to go down. I tend to always run to the right and then change. I go down if it's negative and up if it's positive. And then of course I'll use my straight line tool to draw the line. And there you have it. That's how you graph from slope-intercept form.